is k hat t to the power alpha minus n plus delta plus g k hat t. That equation number 12. So it is, write it down in your exercise book, and from equation number 12 you multiply both sides of equation number 12 with k hat t to the power negative alpha. You get equation number 16. Now you define a variable xt which is equals to k hat t whole to the power 1 minus alpha. You define a variable xt equals to k hat t to the power 1 minus alpha. Then you take logarithm both sides, and if you differentiate with respect to time, you get x dot t by xt equals to 1 minus alpha k hat t by k hat dot t by k hat t. And after simple algebraic manipulation by substituting for kt xt, you basically get this equation number 17. So you start with xt equals to k hat t to the power 1 minus alpha. Then you take logarithm both sides, differentiate with respect to time, and after some simple algebraic manipulation, you will get x dot t is this. X dot t equals to 1 minus alpha k hat dot t k hat t whole to the power negative alpha. Then if you substitute equation number 17 to equation number 16, you can actually get equation number 18. And this is a very simple equation to solve for. So that's the trick over here. So you start with equation number 12, fundamental equation. Then you multiply both sides of equation number 12 with k hat t to the power negative alpha. You get equation number 16. Your objective is to transform this equation number 16 to this equation number 18. So what you actually do, you define xt equals to this, then take logarithm, differentiate both sides with respect to time. With some algebraic manipulation, you get equation number 17. And using this equation number 17, equation number 16, and this definition of xt, equation number 16 can be transformed to equation number 18, which is a very simple differential equation to solve for. So our objective is basically we will solve xt, and once xt is solved, k hat t can be solved because k hat t equals to xt to the power 1 over 1 minus alpha. So we will solve xt first, then we will solve k hat t as xt to the power 1 over 1 minus alpha. This is basically what we're going to do. Dev Agarwal is fine. Are you doing it with me? Dev?
Yes, sir.
Okay. Have you got equation number 18?
Yeah.
Everybody got equation number 18? Okay. Then the solution is this. Integrating factor e to the power lambda t. So you take everything to the left hand side, this part. In equation number 18, you can write x dot t plus 1 minus alpha in plus delta plus gxt equals to 1 minus alpha into s. Then the integrating factor is e to the power lambda t, where lambda equals to 1 minus alpha in plus delta plus g. It's a Bernoulli equation now. Now equation number 18 can be written as in this fashion, and the solution goes like this. So I think you guys should try it. From equation number 18, you should get equation number 19 from here. Try to get it. Simple Bernoulli equation to solve for. Dashrath Mina. Dashrath Mina. Dashrath Mina. Ayush Krishna. Ayush Krishna. Lakshya Kavya. What happened?
Yes, sir.
So I am audible, right? So Ayush is not here. Dashrath Mina is not here.
Yes, sir, you are audible.
Okay. Faisal Rafiq.
Yes, sir.
Have you derived it? Is this derivation
All
fine from
yes,
equation
sir.
number 18 to equation number 19? Have you derived it?
Yes, sir. It's done.
Rohit Anand. Rohit. Rohit Anand. Rajnish Kumar.
Hello.
Rajnish,
Yes, sir.
have you? Is this derivation fine?
Yes, sir. I'm doing, sir. Just joined a bit.
Just still doing. Okay. Do carry on. Sachi Jalote.
Yes, sir.
Derivation fine.
Yes, sir.
So from equation number 19, as I said, for xt is known means kt hat to the power 1 minus alpha is known. So this equation actually what you have solved over here, basically kt hat to the power 1 minus alpha. Now this is going to be the movement of kt hat, this is going to be the movement of yt hat, and this is the movement of per capita capital stop, this is the movement of per capita output. Okay, so the rate of convergence of a particular variable to this steady state value is basically this lambda 1 minus alpha n plus delta plus g. This is the rate at which xt is converging to a steady state value. Okay, this is basically the steady state value. Fine. It's basically all the variable is per capita capital stock, per capita output. They are converging to their respective steady state values at the rate 1 minus alpha n plus delta plus g. This is the convergence rate. So you start with any particular place which is out of steady state, and then you ask the question that how long are you going to take to reach the steady state. In this model, basically the rate at which any particular variable is reaching towards the steady state is 1 minus alpha n plus delta plus g. So the convergence rate depends negatively on alpha. When alpha rises, your convergence is basically faster. Okay. Sorry, the convergence is delayed. When alpha rises, your lambda falls and your convergence is delayed. When alpha falls, your convergence is faster. And in fact, when alpha equals to 1, and we will discuss about this particular case. It's a very important case. When alpha equals to 1, when alpha is equals to 1, it's never going to converge to the steady state. Actually, the steady state does not exist, and the system will never converge to steady state. So you see over here the steady state values. If you can see any solution, what we have done before, this is the solution of KSS. If we go over here, after solving the fundamental equation, this is what we get uh, about the solution of KSS, and one KSS is solved, YSS, and everything is solved. In this case, it's pretty clear that when alpha equals to 1, this particular term is undefined, so actually steady state does not exist. And when the steady state does not exist, there is no point of a particular variable to converging to a steady state. This is exactly, you can see over here, that when alpha equals to 1, it clearly shows when alpha equals to 1, there is no convergence of any variable towards the steady state, because the steady state does not exist. So when alpha rises, your convergence is delayed, and when alpha equals to 1, you will never converge. So this is basically the mathematical solution of the fundamental equation of the Solow model. Okay. So just like see over here, that when t goes to infinity, this term goes to 0. This k hat 0 to the power 1 minus alpha e to the power negative lambda t, this term goes to 0, and this term actually goes to this k hat t equals to k ss hat to the power 1 minus alpha. So when t goes to infinity, this entire system converges to steady state at the particular rate 1 minus alpha n plus delta plus g. That is the rate of convergence. Is it clear? Any question? Namya
Yes, sir.
Swarnkar,
Yes,
is
sir.
it fine?
Yes, sir.
Is this explanation fine?
Actually, I'm deriving it on my own, so I'll take a minute to.
Oh, you are deriving still. Okay, carry on. Standard Bernoulli equation, standard Bernoulli differential equation. So once you get this equation number 18, equation number 18 is the standard Bernoulli with the integrating factor 1 minus alpha e to the power 1 minus alpha n plus delta plus g. So we have already seen graphically that this Solow model is a globally stable model. When your these inner conditions and everything are satisfied, your standard production function is a globally stable and unique steady state, unique interior steady state. So you start with any per capita capital stock out of steady state, you will converge to steady state. What the mathematical solution actually gives you, uh, the, that what is the rate of convergence? What is the convergence rate?
Sir,
Yeah,
sir, in this first equation, so you said the converging rate is lambda.
yeah.
So, that we derived by doing that x dot t by xt, right?
The convergence is lambda. Yeah. But from here, you still do not know what is the convergence rate. But once you solve this equation, you actually see this integrating factor, this lambda, this part is important. 1 minus alpha n plus delta plus g is the rate at which any variable is converging towards the steady state.
Okay, sir.
Your lambda this is your lambda. Lambda is 1 minus alpha n plus delta plus g.
Yes, sir. Yes, sir. Sir, but the converging rate is y dot t by yt, right? And
No,
uh,
that's not convergence rate. Y dot t by yt is the rate of growth of output.
oh, yes, sir. Yes, sir. Um, so,
Harsh Makhwana, derivation is done. Priyangsha,
Yes, sir.
why do we need to solve this differential equation mathematically? What extra information it is giving to me? Graphically, we have already analyzed it. We have already got those information that how the rate of growth is can be represented graphically. Uh, it's a globally stable system. You start with any out of steady state, you will converge to steady state. Everything can be analyzed graphically. We have seen that. But why do we need to solve this fundamental equation mathematically? What extra information it is giving to me?
So I think it gives like the dependence on time of the variables and the perfect equation of the graph.
Perfect equation of the graph.
Yes, sir, like we can approximate, but this is the like
What
function with
what
respect to time.
we have not approximated anything in that graph. In that graphical analysis, we have analyzed that you start with anywhere, you converge to steady state, your steady state is stable. If any parameter changes, S changes, N changes, delta changes, how your steady state changes, everything can be analyzed graphically, and we have seen that. Even the how the rate of growth of capital in the short run, rate of growth of capital in the rate of growth of output in the short run, long run, everything we have analyzed graphically. But still, why do we need to solve this equation? What extra information we are getting by solving this fundamental equation mathematically?
I have to think. Sir, it is giving the variables as a function of time.
So variables as the function of time we are solving. Fine. Then what? Why do we need that?
We can also find the rate of convergence.
One is
I
obviously
mean the
true, the rate of
speed of
convergence, how long,
convergence.
yeah, how long are you taking to converge to steady state? That is one extra information you are getting. Another information is, as you said, that once I solve this KT for each and every time period, then if I substitute those values of KT here, so once I know the value of KT for each and every time period, I can get the solution of YT for each and every time period, CT, per capita savings, wage, rental can be solved. So what this particular thing is giving me is basically the steady state value only. What is the steady state capital stock? What is the long run value of capital stock? Substitute that in a production function, you get the long run value of output. Can be solved by solving this fundamental equation at the steady state. But if you want to say that how to what is the time path of the convergence of capital talks to steady state, you need the solution. And once you have the time path of KT, correspondingly, you can get the time path of YT, CT, ST, WT, RT. So after solving that graph mathematically, we get the time path of capital stock, per capita capital stock or capital stock over the time. It gives me how the time path is converging to steady state, how long it is taking time to converge to the steady state. And not only that, the solution of capital stock for each and every time period obtained by solving the differential equation allow me to solve output for each and every time period, consumption for each and every time period, savings for each and every time period, wage for each and every time period, and rental for each and every time period. So unless and until I solve the differential equation, I cannot solve the time path of each and every variable. I can get the steady state values. What is the long run value? But how all those variables are converging, what is the time path they are following, how long they are taking to converge to the steady state, all this extra information can only be obtained by solving the fundamental equation mathematically. Am I clear? You see, You can get K1, K2, K3, K4 dot 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 from equation number 12. Similarly, you get Y1, Y2, Y3, Y4 dot 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 from equation number 21. Similarly, if you substitute this, your output is already known, that what is your savings, S into IT. So you multiply S to both side of equation number 21, that will give you the time part of the per capita savings. Once your savings and output is known, YT minus ST, you get time path of consumption. So entire time path, all the time path you'll get. Right?
Yes, sir.
Very good. From equation number 21 or equation number 21, another important thing to note over here, once a system reach the steady state, then equation number 21, let's say, boil down to, after output reaches the steady state, you see equation number 21 boils down to YT equals to YSS hat whole to the power 1 minus alpha by alpha multiplied by YT, AT. Per capita output equals to some constant. Once it's reached the steady state, per capita output YT is some constant, which is that, what is that constant? This Y hat SS to the power 1 minus alpha by alpha multiplied by AT. This also says that if you differentiate this with respect to time both side at the steady state, your Y dot by Y equals to A dot by A. And again, per capita output is growing at the rate of technology in the long run. Getting my point? Is it visible?
Yes, sir. Yes, sir.
Laksha, is it visible?
Yes, sir.
We have already shown that at the steady state, per capita output is growing at the rate of technology. The same thing is visible over here. Once economy reaches the steady state, the term in this bracket boils down to YSS hat to the power 1 minus alpha by alpha, which is the constant. So Y hat T equals to a constant multiplied by AT. So you differentiate both sides with respect to time, you get y small y dot by y equals to A dot over A at the steady state. So again, per capita output is growing at the rate of technology at the steady state, and hence capital Y is growing at the rate N plus G at the steady state. But obviously, these are long run growth. In the short run, just like you differentiate number 21 with respect to time, obviously the y dot by y is not equals to A dot by A when this particular term in the bracket is not a constant. The term in the bracket is not constant when it is short run. And your y dot by y is not equals to A dot by A. It depends on a lot of stuff. It depends on lambda, and lambda depends on n, delta, g, alpha, everything. But once this reaches the steady state, the term in the first bracket is a constant, which is YSS whole to the power 1 minus alpha by alpha. Now you differentiate both sides with respect to time, you get y dot by y equals to A dot by A. So in the long run, per capita output is growing at the rate of technology, output is growing at the rate of population growth plus technological growth. Long run. But in the short run, no. The short run depends on a lot of stuff. Short run growth depends on a lot of stuff. It depends on alpha, it depends on n, delta, g, s, everything. जो मैं पहले भी बोला था, solution fundamental equation solve करके कि मुझे वही सब result मिल रहा है. But what extra we are getting, the convergence rate, that if you are out of steady state, how long you are taking to converge to the steady state, it depends on the value of alpha, n, delta, and g. And also the solution of this differential equation gives you the time path of kt, yt, ct, st, everything. Each and every time period, what is the solution? You can get that. Fine. Any question till now? Anubhav, Anand?
Yes, sir.
Any question?
No, sir.
You understood everything? Very good.
Yes, sir.
So this is one part. Another part now, as I told you, that uh, output is growing at the rate of technology in the long run. Per capita capital stock is growing at the rate of technology in the long run. And then the question is whether I can measure technological progress of all the countries. Then if I can measure technological progress all the countries, I have a data of per capita capital stock. I will simply check whether the rate of growth of per capita capital stock obtained from the data is actually in the long run, whether it is rate of growth of technology or not. So this is basically the procedure of doing it. So you see, I am starting with the same production function, which is written over here, equation number 9. And this equation number 9 can also be written as it is kt to the power alpha at nt whole to the power 1 minus alpha. Now if I decompose, it basically gives you at to the power 1 minus alpha, kt to the power alpha, nt to the power 1 minus alpha. So this equation number 9 I am writing in that fashion: at to the power 1 minus alpha, kt to the power alpha, nt to the power 1 minus alpha, and I am defining at to the power 1 minus alpha is bt. And this is exactly what I have done over here. Define bt equals to at to the power 1 minus alpha, then equation number 9 becomes yt, capital YT, equals to capital At to the power 1 minus alpha, capital Kt to the power alpha, and capital Nt to the power 1 minus alpha. Now what I have done, I have taken logarithm both side and differentiated both side with respect to time. See over here, I get rate of growth of output equals to alpha, rate of growth of capital stock, plus 1 minus alpha, rate of growth of population, plus b dot t by bt. So capital YT equals to at to the power 1 minus alpha, kt to the power alpha, nt to the power 1 minus alpha. What I have assumed, suppose bt equals to at to the power 1 minus alpha. If that is so, then ultimately the production function becomes yt equals to bt, kt to the power alpha, nt to the power 1 minus alpha. Take logarithm both sides, differentiate with respect to time, you get equation number this. So objective is from the data, calculate b dot t by bt. Once you calculate b dot t by bt, you can calculate rate of growth of total factor productivity. This a dot t by at will be 1 over 1 minus alpha b dot t by bt. So from this equation, I will calculate b dot t by bt. Once b dot t by bt is known, a dot t by at can be calculated using this equation. And this a dot t by at is basically my rate of growth of technology. Sometimes it is called also the solo residual. From the data, this is my GDP growth. So I have GDP for each and every time period. So its growth rate can be calculated. I have capital stock data available. So I can calculate rate of growth of capital stock. Population data for each and every country for each and every time period is available. So I can calculate rate of growth of population. So what we will do, I will calculate b dot t by bt equals to y dot t by yt minus alpha k dot t by kt minus 1 minus alpha n dot t by nt. B dot t by bt is calculated, then a dot t by at is also calculated. This is how Solo calculated the rate of growth of technological progress for different countries in his paper. And suppose USA. So I have suppose rate of growth of technological progress data for USA calculated in this fashion from 1960 to 2010. Okay, obviously I can calculate the average rate of growth. So rate of growth is known, I'll simply calculate the average. Just a second. Yeah. So the GDP growth can be calculated from the data, capital stock growth can be calculated from the data, population growth can be calculated from the data, even alpha, it is the share of capital in national income, which is RK divided by Y. That also can be calculated from the data. So everything is known. Then I can calculate Y dot by Y minus alpha K dot by K minus 1 minus alpha N dot by N. I get B dot by B. That B dot by B will give me the technological progress data A dot by A. For USA, let's say I get this data for 40 years. I get the average of that. Then what I have to match, suppose I'm getting average something like 2% for last from 1960 to 2010. Average rate of growth of technological progress in USA is basically 2%. Now, I also have per capita output data of USA from 1960 to 2010. I will calculate its average rate of growth and I will check whether it is matching or not, because Solo model is saying in the long run, per capita output should grow at the rate of technology. And this is exactly what Solo done it. And he has shown that, okay, in developed countries, it is actually matching. That is the long run per capita growth rate is very close to the TFP growth rate calculated in this fashion. Okay, you see that the way we are calculating B dot T by BT is as a residual of this equation. Y dot T by YT minus alpha K dot T by KT minus 1 minus alpha N dot T by NT. This is the residual, which is giving me B dot T by BT. So B dot by BT is basically a Solo residual because it is calculated by Solo first time. As a residual of this equation, it is called the Solo residual. Using this Solo residual, I can calculate rate of growth of technological progress A dot by A. This is called growth accounting. This methodology that I have briefly explained over here, it is called the growth accounting. And this is basically what people has done over the time. This is for USA from 1948 to 2010. What they actually find out that this is multi-factor productivity, which is basically your TFP in this case. From this entire time period, 1948 to 2010 is basically 1.4%, 1948 to 73, 2.1%, 73 to 95 is actually fallen down to 0.6%. Then again from 1995 to 2010, it has increased over the time. Okay, and you also get the contribution. This is basically the contribution of capital. This is the contribution of labor, rate of growth of labor, rate of growth of capital, and this is then we calculate the rate of growth of technological progress in this fashion. So this is how Solo calculated rate of growth of technology using the growth accounting principle. Over the time, people has gone for different precision of this equation. More precision has been actually uh, introduced over here in this growth accounting framework, but this is basically briefly for this class. This is how people calculate rate of growth of technology from the data. Clear? Jathar Soneji?
Yes, sir, it is.
Clear, right?
Yes.
Okay. हाँ बोलो कौन?
Sir, so can you
Who's this?
show the previous slide?
Yeah.
One more back. Sir, where you showed the calculation of previous topic, like before this.
Previous topic, that is the solution of this differential equation.
Yes, sir.
Okay.
Sir, you said in the long run, only the y hat SS 1 minus alpha by alpha,
Yeah,
that part
when
will remain, and
all part
what?
will disappear.
Yes, sir. So I didn't understand how,
When t goes
like
to
in the
infinity.
short run, we have. Achha,
When t goes to infinity, this term goes to 0. As a result, this term goes to 0.
Okay.
And only thing that remains is YSS hat to the power 1 minus alpha by alpha, which is the constant.
Okay, sir. And in the like the topic we just studied, can you go to that slide? Sir, that ratio TFP Sir, it is equal to uh, growth rate, right?
This
This
is the
ratio.
growth rate of technology, yeah. Technological
So,
growth.
sir, that was y hat steady state. Y hat steady state divided by the growth rate. I mean that this ratio was equal to something else. I actually forgot that ratio. Like we have actually proved that this
Who's this?
a dot t by at this is
A dot t by at in the long run, it is y dot t by yt. A
yes
dot t
sir.
by
So
at in the long run. That is the prediction of the Solo model. Solo model says that in the long run, per capita output is growing at the rate of technology. What I am
yes
saying,
sir.
this
So
is how you
this is
calculate technological progress from the data.
acha, from the data. Okay. Yes, sir, got it.
Sagar, Suman, data means your
Yes, sir.
GDP. Your GDP data is available. This is your GDP rate of growth. Obidip Khare. Y capital Y dot by Y, it is the rate of growth of GDP, which can be calculated from the data. Capital K dot by K, it is the rate of growth of capital stock, can be calculated from the data. Capital N dot by N is the population growth, can be calculated from the data. Alpha is basically your capital share in national income, RK divided by Y, can be calculated from the data. Then if everything is known, then B dot by B can be calculated from this equation as a residual. Avidit,
Yes
I'm
sir.
talking to you. Yeah. And once B dot by B is known, I can calculate A dot by A from the data. Now, what is my objective? What I'm doing it, I'm just checking whether the prediction of the Solo model is matching or not. If the prediction of the Solo model is matching, again, I have a data of per capita capital stock for a particular country over the time. I will calculate its average rate of growth. And if the Solo model prediction is true, then this average rate of growth of the per capita capital stock and the average rate of growth of this A dot by A should be very close to each other.
Yeah.
And
Yes,
that is
sir.
actually very close to each other for the developed countries. It is not true for the developing countries like India. Let's say you go to Pakistan, India, Singapore, Malaysia, it won't hold. But you go to Japan, you go to USA, you go to UK, France, Germany, developed countries, OECD countries, it holds. Sagar, Suman,
Got
Yes, sir.
clear? Any question?
Yes. No, sir. It's fine.
No, right?
No, sir.
Okay, so this is briefly about, and people actually spend a lot of time in this particular table, that why, let's say you see over here, the contribution of capital is really fallen down in the period 1970 to 95 in USA. Labor composition, the contribution of labor in this growth accounting is almost pretty stable USA, but there is a fluctuation in capital contribution, and as a result, there is a fluctuation in the technological progress calculation. Okay, so this is it. So this is basically what I have said over here, rate of convergence, and this also I have explained. Now, one particular part, this is also a very important derivation, equation number 24, and I don't think I'm going to teach that. Okay, before doing all this, one thing, let me just show you over here, that why I am doing this part over here. You see, rate of growth of technology and rate of growth of per capita output. This is a 45-degree line. Okay, there are some countries, obviously, let's say Argentina, Chile, Colombia, over here Japan, SGP. Well, for some countries, they're very close to this 45-degree line, but that basically gives me that prediction of the Solo model, per capita output is growing at the rate of technology. But there are some countries that's something far away from over here. But from here, people realize, okay, there is something missing maybe in the production function. Another way people saw what people have done, this Barrow and Salai Martin especially, I don't know whether I've mentioned it somewhere. Uh, let me see if I have mentioned somewhere. Paste diagram. Forget it, forget it, forget it, forget it, forget it. No, I think I have not mentioned it. One is that part. Another part, Barrow and Salai Martin realize. So using that simple production function, equation number 9, Barrow and Salai Martin has calculated this convergence rate, because you see the population growth data is available, depreciation of capital stock data is available, G can be calculated the way I have shown in through accounting, this growth accounting. Alpha is known to me. That means I can calculate the convergence rate for different countries, to how long it is taking to converge to the steady state. What they have realized, Barrow and Salai Martin, from their research, that this particular equation, if I follow, it actually gives me a very fast convergence to the steady state, and which is not matching with the data. So there are two ways people realize that that production function, that kt to the power alpha, at nt whole to the power 1 minus alpha, there are some element in this production function is missing. One is this part. If I calculate the convergence rate with this production function, it gives me a faster convergence. And second part is this particular figure. But for some countries, rate of growth of per capita capital stock and rate of growth of technology, they're very far away. And for that, what they have done is pretty simple. And this is basically, I'll just briefly mention over here. They actually introduce this kind of production function. Yt equals to kt to the power alpha, h to the power beta, atnt whole to the power 1 minus alpha minus beta. This ht is basically your human capital. They introduced that. And what they found, once they introduce this human capital and they calculate the convergence rate with this production function becomes 1 minus alpha minus beta n plus delta plus g. They calculate alpha from the data, they calculate beta from the data, n delta and g is available for me, and they calculate the convergence rate for different countries, and they found that convergence rate are very close to that is matching with the data. So after that, people started analyzing solo model with this kind of production function, which has a capital, which has a total factor productivity AT, which has a population NT, but they also introduce a human capital over here, HT. So you see it's still a constant return to scale production function with KT, HT and effective labor force. Okay, so if KT, HT and the effective labor force is increasing at the rate of lambda, output is also increasing at the rate of lambda. It's still constant return to scale production function, but they introduce this HT to the power beta over here, human capital. Why? Because without HT, the convergence rate is 1 minus alpha n plus delta plus g is giving me a very faster convergence. People have analyzed that. But once they introduce this h to the power beta over here, the convergence rate of capital stock to steady state, output to steady state, it becomes 1 minus alpha minus beta n plus delta plus g. Because of this extra term beta, the convergence has fallen down and started coming much more closer with the data. Okay, so people started analyzing this kind of production function with the solo model. Okay, then one particular model I will actually explain over here. I'm not going to this particular model is very important. This Mankiw, Romer and Well 1992 paper is a very important paper that actually examines solo model empirical validity in a different way. But for that you need to know econometrics. You do not know econometrics, and that is why I will not go to the estimation. But I'll briefly explain. If you have this kind of production function now, kt to the power alpha, h to the power beta, at nt whole to the 1 minus alpha minus beta, and then how does the solo model is analyzed with that, with physical capital stock and human capital. Okay, फिर से मैं बोल रहा हूँ, why do I introduce human capital? Because without human capital, the convergence rate of output, capital stock, and everything to the steady state is 1 minus alpha multiplied by n plus delta plus g, which we have solved by solving this fundamental equation mathematically. And they have calculated for different countries this convergence rate over the time, and they found that this convergence rate is giving me a very faster convergence to the steady state, and they realized that something is missing in the production function. This is Barrow and Salai Martin, and then Barrow and Salai Martin introduce a human capital, this kind of production function, and the convergence rate become 1 minus alpha minus beta multiplied by n plus delta plus g. Because of this extra beta, convergence rate fallen down, and it's coming closer, and it came closer to the actual convergence just getting from the data. So people realize, okay, this should be the better production function to analyze. And then people started analyzing this production solo model with this production function. And this is how it goes. So this is the part we will do that. And then the last topic of the solo model we will discuss about this. As I said, when my savings rate changes, I have a unambiguous impact on capital stock, output, consumption, and everything. But when savings rate more or less changes, I do not know what is happening to my consumption. And this part is very important. It's called the golden rule level. And that part we will also analyze. Okay, fine. And we will analyze that with the simple production function first, and then we'll go. So this is the part we will now analyze, then we will go to this human capital analysis after that. Okay, I think, yeah. Any question till now? Jagrut, are you here?
Yes, sir.
फिर से मैं दशरथ को एक बार पूछता हूँ. दशरथ, मीना, are you here? Dashrath? Dashrath, Meena, are you here? I have removed you from the class and you again logged in, but even after logging in, you are not attending classes. Dashrath, Meena. I am removing you again from the class. Okay, any question till now? Anybody? Jagrut, question hai kuch?
No, sir.
No, it's fine, right?
Yes, sir.
Acha, you guys tell me one thing. यहाँ पे, in this solo model, we have assumed that a particular fraction small s of total income y is saved. And then we derive this fundamental equation. Your savings is small s multiplied by y. So capital S equals to small s multiplied by y. If I say that a particular fraction, okay, if I say that you save your entire labor income, how does the fundamental equation change? The question is, फिर से मैं बोल रहा हूँ, the way we have analyzed solo model till now, we have assumed the total income, the sum of the capital income and the labor income is basically my total output Y, because WL plus RK is basically Y. The way we have derived this fundamental equation with the assumption that a small fraction S of the total income Y is saved. And that is basically my investment. So capital K dot T plus delta KT equals to S into capital YT. That is basically my equation that we have started with. Now I am changing this a little bit. Suppose I'm saying that your entire labor income is saved. How does the fundamental equation look like? Let's see. Then I will realize, okay, you understood solo model properly. Instead of a fraction of total income being saved, you are saving your entire labor income. How does the fundamental equation change? So let me go to my Word document. Let me focus it. So till now, this is what we got. Capital K dot T plus delta KT. This is basically your investment. Delta KT equals to small s, capital F, capital KT, comma, capital NT. Because this is basically your out YT. If capital F, KT, NT is basically your YT. This is what I got. And this is how we analyze solo model. Now what I am saying, you are not saving a fraction of your total income. You are saving only your labor income. How does the fundamental equation look like? कौन बोलेगा? लेफ्ट हैंड साइड में कुछ चेंज नहीं होगा. दिस इज इन्वेस्टमेंट, फाइन. राइट हैंड साइड क्या होगा? विच इज सेविंग्स. कौन बोलेगा?
WL
WN, right?
N.
Very good. So WT NT, which is equals to, what is WT in terms of production function? What is WT from the profit maximizing condition? Yeah.
1 minus alpha times KT
No,
to
मैं
the power.
alpha तो नहीं, यहाँ पे alpha है. I'm doing with a simple production function. ये production function जब Cobb Douglas होगा वो alpha to alpha सब आएगा.
MPL,
MPL, how do you calculate MPL?
del y upon del L.
Very good. So it is, if let me just write it down from mathematically, basic math. So in the denominator you get del NT, and in the numerator you get del this part, f of KT/NT, right? that multiplied by NT, right? That's basically your savings. Fine. This is the fundamental equation. Then what is the fundamental equation in terms of per capita? You substitute both side by NT. Copy it over here. So let me just write down this fundamental equation in the per capita form, because I have to ultimately analyze it in terms of per capita. Equals to this part. Right? Which he said correctly, that if I have a Cobb-Douglas kind of production function in the per capita form, this will become 1 minus alpha kt to the power alpha small kt and ultimately if I do some analysis, it basically k dot by k nt. Suppose we have no technological progress and nothing, so it will be this term will be ultimately, if I write down the production fundamental equation in the per capita form, will ultimately boil down to small k dot t small k small kt and give a dot over here plus nkt equals to actually plus n plus delta kt. So put my delta over here, put it in the bracket, and that actually gives me this. Now this is the fundamental equation. So I can take this n plus delta term and kt term to the right hand side. Minus term over here. Again, the same thing. Now you have a, you set small k dot t equals to 0, you get the steady state value of capital stock. Once steady state value of capital stock is known, you have this output and everything solved. So you have to understand what is the question. Is it the entire income he is saving, only the labor income is saving, or only the capital income he is saving, or a fraction of labor income is saving? If I say the a particular S fraction of the labor income is saved, then this part will be multiplied by something S. And this part will be multiplied by something else. If a fraction S of the entire labor income is saved, entire labor income is saved, that means small s equals to 1, small s equals to 1, small s equals to 1. This is the fundamental equation now. Similarly, you guys tell me, if a person is saving his entire capital income, how does the fundamental equation per capita form looks like? Equals to, this part won't change at all. This part will remain unchanged. Yeah, now question is, I have derived the fundamental equation when the individual is saving his entire labor income, and when individual is saving his entire capital income. How does the fundamental equation look like?
plus alpha kt alpha.
फिर से बोलो एक बार. फिर से बोलो एक बार.
Alpha into kt alpha.
Okay, that means this kt alpha
Multiplied by alpha.
and what is that? It is f prime kt into kt, right? rt kt, right?
Yes, sir.
Alpha into kt to the power alpha is basically in the in Cobb-Douglas production function is basically taking that form, right? So this alpha kt to the power alpha is nothing but rt kt, but rt is f prime kt. So ultimately, if we take a functional form, which is general functional form, this will be this equals to, this is, oh, let me write it down over here, then I'll copy and paste. It will be f prime kt small f multiplied by kt. And which is for the Cobb-Douglas production functions taking this form, because f prime kt into kt is basically your rt kt is basically your capital income. And that capital income in the Cobb-Douglas form is basically alpha kt to the power alpha. Now again, you solve your KSS, you solve your YSS, CSS, you solve this differential equation mathematically the way we have shown. Nothing is going to change. So that will be very clear. So what you're exactly doing. It could be possible you are saving your labor income or capital income or fraction of labor income, fraction of capital income instead of your that part, your entire income. Okay. Is it possible to have a solo model? Next question, where you are saving your entire income? That means sum of your labor income and capital income entirely you are saved. That means this. Your investment equals to your savings, and what is your savings is your total output production. Whatever is produced is saved. So actually, in the per capita form, the production function, the fundamental equation actually, if you take a Cobb-Douglas kind of production function, is basically this. Kt to the power alpha negative n plus delta kt. S is equals to 1. and I can solve my steady state capital stock and everything. What is the problem here? Can we I can analyze this theoretically. Is there any problem practically this, but is there an economic problem behind this assumption? Solo says a fraction of your income stays. I said that it is possible that only a labor income is saved, only a capital income is saved, only a fraction of labor income is saved, only a fraction of capital income is saved. Is there any problem with the assumption if we take if we build a model with the assumption that your entire income is saved? This is the fundamental equation. Then I can solve this differential equation. I can solve the steady state value. But is there
Sir,
any
if
problem?
nothing is being consumed, then why
Very
is it
good.
being produced?
Very good. Very good. Because you are dead then. If you cannot consume anything, you are dead. So this particular fundamental equation has that problem. So that is why this consumption is important. And not only that is important, that is why it is important to find out a capital stock that maximizes consumption. This is still we have not studied. We have to find out the steady state value of capital stock, and accordingly we find out what is going to be the steady state value of consumption. Now we have started asking question, what is my welfare maximizing steady state capital stock in the solo model? What is the criteria of welfare maximizing? I am going to find out that steady state capital stock that is maximizing my steady state consumption. Then we compare if that particular capital stock that is maximizing my steady state consumption, is it really my steady state capital stock of the solo model that I'm calculating? This is the part is still we need to study in the solo model alongside this human capital. Because the consumption is important, because without consumption you are dead. And Solo knows that. That is why Solo says that only a fraction of income is saved. Rest of the part is consumed, because without consumption you are dead. Now the question is, my capital stock steady state depends on savings rate, small s, and there is a particular savings rate that maximizes my consumption. That means there is a particular capital stock also in the steady state that maximizes consumption. What is that capital stock? That is basically the question people asking. That is my welfare maximizing capital stock. A steady state capital stock maximizing my steady state consumption. We have to calculate that. And technically, this is called the golden rule level of capital stock. So what is the golden rule level of capital stock? Golden rule level of capital stock is a steady state capital stock that maximizes the steady state consumption. Getting my point? Okay, so this is we're going to analyze. Today is still, there's no time left actually. So we will analyze in the next class. So consumption is important. You have to consume, otherwise you die. And that is why in this solo model, your entire welfare of a particular individual, you do not have a utility function. Generally, utility is basically the welfare, a proper measure of welfare in economic modeling. But we basically do not have a utility function in this model. Consumption is taken as a measure of welfare. So what people are actually concerned after that what is that steady state capital stock that is maximizing my steady state consumption? Technically, it is the golden rule level of capital stock. The question is, what is golden rule level of capital stock? The golden rule level of capital stock is that steady state capital stock that is maximizing my steady state consumption. We will analyze that, and we will find that golden rule level of capital stock and the steady state capital stock that we have already, let's say this value, my solo, yeah, and we will see that this is different from this. Let's say the steady state capital stock that we have solved till now, this value that depends on S in delta in this fashion. we will see in the solo model the steady state level of capital stock that will actually maximize my long run consumption is not this. They are different. And here the government policy comes into picture. And how could I ensure my steady state capital stock will converge to golden rule level of capital stock? Can I influence S? Can government influence S in such a way so that the KSS is always equals to KG, the golden rule level of capital stock, or not? This is basically the part, the very technical part, but actually why people actually gone for different kind of other model other than solo is basically this, because this is also a problem with the solo model that cannot be solved in the solo model, and we'll discuss that more in detail. So the next topic will be the welfare maximizing capital stock in the steady state. How we measure welfare, consumption maximizing capital stock at the steady state, known as the golden rule level of capital stock. Fine, Sachi, it is fine. Sachi, Jalote,
Yes, sir.
this is the next topic we'll pick up.
Yes, sir.
So I think the introduction part is fine, right? I have to consume, otherwise I will die. Now the question is, what should be the capital stock at the steady state that maximizing my steady state consumption? That is my welfare maximizing capital stock, known as the golden rule level of capital stock. This is we're going to solve for the solo model. Next class. Divyang Sonkar. Divyangs, are you here?
Yes, sir.
Clear? Discussion?
Yes, sir.
Clear, right? Now, what
Yes,
is the golden rule
Yeah.
level of capital stock? Divyangs, please unmute yourself.
Yes, sir.
What is the golden rule level of capital stock I have just defined?
Uh,
Hmm.
Sir, actually, I was washing my hands, so I didn't hear.
You are not washing your hand. You are inattentive in the class. इसीलिए मैं तुम्हें पूछा. अच्छा, वो छोड़ दो. What is the convergence rate we have calculated today in the solo model? Divyangs,
Yes, sir.
what is the convergence rate?
Sir, it is uh, one one minus alpha.
1 minus
to the
alpha is the into
e to the power minus 1 minus alpha.
is the convergence rate. E to the power minus 1 minus alpha is the convergence rate.
No, sir.
तुम कितने कितने घंटे से अपना हाथ धो रहे थे? How long you are washing your hand?
सर बीच बीच में वॉइस चली जाती है तो नहीं.
बीच बीच में वॉइस चली जाती है. It is impossible. As I told you, generally I do not use the internet connection given by the institute. Those connection is weak, I know, but I spent my own money to get a proper connection, and then I'm using that. तुम्हें अनम्यूट करने के लिए मैं नहीं बोला था. दिव्यांश, प्लीज अनम्यूट योरसेल्फ.
यस सर, यस सर, यस सर. सर
ठीक है, आज तो तुम हाथ धो रहे थे. लेट्स सी. Why two countries income level at the long run is different? What is the prediction of the solo model? Per capita output of two countries are different in the long run. What is the answer of the solo model? Why they are different?
Sir,
what are the factors?
K is different.
K is different. Why K is different? I agree, K is different. K at the steady state is different. The question is why K at the steady state is different for two different countries?
Sir,
What is the prediction?
because,
So, bolo.
because S is different
And
and rich countries are technological, like
technology does not
techno.
appear. Technology does not appear at all.
Okay,
Standard 2 or 3 factors. AC is one factor.
like
What are the other factors?
saving rate
Savings
of
rate is a factor.
population,
Savings rate of population. मैं तुझे कभी
savings
नहीं सुना हूँ
rate.
savings. बोलो बोलो बोलो.
No, sir. Population's growth rate
Okay, which is
and
denoted by
savings.
in this solo model population growth rate is denoted by. Okay, and anything else? SN, fine. And anything else?
Uh, delta.
Delta. What is delta?
Uh, um, uh, Depreciation.
Depreciation of the population. Whose depreciation? Population.
Capital. No, sir.
Very
Capital.
good. Very good. This is, you are saying that, okay, this is for the simplest possible solo model. This is the thing. If I introduce a technology in the solo model, does your answer change by any way? Are these are the factors only that affects K?
Yes, sir.
So K is not affected by any other factor. If I introduce solo, if I take an augmented solo model, that is solo model with the technological progress.
Hello.
You said that it's a simple solo model S, N and delta. They are different, K is different, Y is different.
Yes,
If I
sir.
take an augmented solo model, the solo model augmented by
Yes.
the technological progress, A,
Yes, sir.
are these only factors or anything else?
No, sir. G will also come.
Okay, G will also come. कहाँ पे आएगा, न्यूमरेटर में या डिनोमिनेटर में?
Sir,
In the calculation of K, what does the
yes, sir.
denominator?
Denominator.
So at least 2 दिन पहले तुम हाथ नहीं धो रहे थे, आज हाथ धो रहे थे. खाना अच्छा था घर में इसलिए हाथ धो रहे थे. हाँ?
No, sir. Actually, sir. सर मतलब हो गया था, गंदे हो गए थे.
गंदे क्यों हो गए थे? तुम तो पढ़ाई लिखाई कर रहे थे.
Yes, sir. सर चिपचिपा रहे थे actually.
चिपा रहे थे. Very good. चलो ठीक है. We will meet again tomorrow at 2 o'clock. I am ending the lecture today over here. So please practice the derivation part. This fundamental equation का जो mathematical solution आज मैं किया हूँ. So that is why I have not started this consumption analysis today, because that is a rigorous part. Please practice how to solve that. Okay, everybody. So we will start the new topic tomorrow, that golden rule level. Very good. We'll meet again tomorrow. Thank you.
Thank you.
Thank you, sir.
Thank you.